So on the workbench here I have two 150-pound class 304 stainless steel. These are 8-inch blind flanges for 8-inch pipe, really big chunks of stainless. And I have to machine both of these the same way except for different. You'll see I got to put big holes in both of these. It's just probably not going to be real easy, but I'm hoping to remove as much stainless as I can while simultaneously removing as little as possible, and hopefully that'll make sense in just a second. Let me get you over here and show you, and I'll explain kind of what these are for, and it will maybe make a little more sense. Not going in industry, going in the scientific world. It's going on an experimental big vessel. You'll see. I'll explain it to you. So let me show you. So look at how large that flange is. Pretty good chunk of stainless there. I'm guessing 13 to 14 inches off the top of my head, probably a good inch thick. Now what I've been asked to do is to machine a big hole in the middle of this in a bolt hole pattern. So this 4-inch PVC pipe flange can be bolted to the face of this flange. It'll actually be the other side. This is the gasket side. So we have to remove a lot of stainless from the middle of this. Now there's a lot of ways you could go about it. You could set this up in a CNC mill, would be the easiest way. Just cut your circle, and you'd be left with a big slug that falls out. You wouldn't have to remove all that material. Or you could set it up in a lathe, like I'm going to do, because I don't own a CNC milling machine, or a rotary table big enough to put this on my manual mill. So what I'm going to do is set this up in the lathe and use a single point trepanning tool and plunge into the face of this and try to remove a big slug of material while just removing a little with the tool. That's kind of be the plan. Now, when we finish this one, I've got another one to do, but it's on a smaller scale. So that's a 2-inch stainless steel, blind flange. So much smaller hole in this one, and a 4-hole bolt pattern. So let's go. Well, first, let's just do a quick and dirty layout on this thing so I can stay on track, and then we'll take it over to the lathe and see if we can't successfully remove a big chunk of stainless without breaking anything. So the first thing that I want to do is we got a center mark there. Just going to knock that down. I'm going to come in with a center punch, and I'm going to get me a little punch mark there, and that'll give me a good place to start my layout from. So the hole that we're putting in here, it does not have to be a super precise hole. It just needs to be big as this opening. So 4.3 inches and 30 thousandths. So we will 4.3 divided by 2. So 2 inches, 150 thousandths. So 2 inches, 150. And this is just for me to go by, really, while I'm plunging on the lathe. So I'm use my calipers here, just to get me close. And there we go. There is our hole. That's the chunk we need to remove. So we got the big 4-jaw in here today. Let's see if I can get this in here without smashing a finger off. So I just measured across this, then measured with a tape measure across my jaws. That way I can just set this up in here and it should be pretty close. And relatively close to dialed in without, even having the part in the lathe. So that's the way I did it. Then just a dead blow across onto the face of this to get it seated onto the jaws. That looks good. Now we just gotta take us a dial indicator and dial it in, and that'll get us close enough to center. We've got a mag base off the compound there, and a thousandths best test indicator. Come in, load it a little, and I'm pretty far off there. So we need to go in. So, okay, loosen the low just a little. And really, for this job, that is good enough. I am going to try to get it just a hair closer though. That's going to be plenty good enough for what we're doing here. So there's a look at the tool that we're going to be using. It's been ground on before, but you can see it looks like a parting blade, but it's got a slight radius to it, so it can, be plunged into the face of a rotating part. And it's sized from 79 millimeter to 130 millimeter. So this hopefully will go in here without rubbing. That's the plan. I'm going to be feeding in with a compound, so you'll see. Going to be using coolant as well. So I'm hoping this will work. If it doesn't, if it does rub, then I'll just have to sidestep, cut a little bit, come back, plunge, just to give this tool some clearance. We'll see. I'm hoping it should work. All right, just about ready. So made sure that the tool is square with the work. So my blade is going to go in nice and straight, not go in sideways and then start rubbing. If I did this a lot, I'd probably, I'd attempt to power feed. I'd get this set up in a way where I knew the proper speeds and feeds, what this thing liked, but being stainless, this is the first one that I've done, I'm going to just use some coolant, feed by hand. That way if I feel it start acting up, I can back off or I can speed up. I get the feel for it. So that's what I'm going to do. And safety glasses for trepanning by hand are a must. The thing with stainless is you just don't want to let it stop cutting and start rubbing. You can work hard, and this being 304 though, it should act okay. I'm going to sidestep this hole, give this chip a little more clearance to get out of there, because what will break this tool will be the chips binding up and welding inside of there. So I'm just going to come in to the side a bit and sidestep it. we go. Did it. That was painful. So that went about as expected. Sidestepping it was a must to give these chips room to curl and get out of that hole. It was completely up to the face of the tool post here, as deep as that will really go. So it worked. Well, we'll just clean that up a bit. That's good enough. So this spray-on marking fluid, it's awesome. Covers a large area very quickly. The problem with it that I have is that if you use it in an enclosed building, it'll almost run you out. The fumes off this stuff it's gnarly. Give you a buzz. So I'm just setting the flange on there, centering it up with the hole, and then using a transfer punch, basically, just to scratch the blue. Anything more that I do to this than what's necessary accuracy-wise is just a waste of time. And I'm not making much on this already, so just keep it good enough, and that'll be good enough. So we are over here at the DeWalt drill press fixing to tap all of the holes in this bolt hole flange, bolt circle. So the idea here is to go almost all the way through this flange, leaving about 3/8 of an inch, before we pass all the way through. So I'm going to pilot drill them all. Then I'm going to go to the same depth with the drill for our 5/8 tap. I will tap all these, and then these will get studs screwed into these holes with a little Loctite. Now the reason why I'm not going all the way through this flange is because that will leave a direct leak path from inside of this vessel to the outside. Now this is not a pressure vessel. It's going to be at or maybe just slightly above atmospheric pressure. So we're not weakening this thing or nothing like that. I just want to assure that this thing does not leak through the bolts, out. So that's what we're doing. I've already got my depth stop here on this drill set, so I can get good repeatable results all the way around this thing. So our handy dandy drill index that I keep on every machine, basically, both the drills, milling machine, lathe. It's saying for 5/8 11 we need a 17/32 drill. So I went over to my pile of drill bits that are larger than 1/2 inch, and I could not find a 17/32 drill to save my life. But I ended up digging for about 30 minutes in the shop in a drill bit drawer. It's actually a filing cabinet drawer, and at the bottom of it lied the elusive 17/32 drill. And that filing cabinet is housed or holds drill bits that are rough. Either they need resharpened, they're beat all to pieces, and I think that I can save them, so I hold on to them forever. This is one of those. So I've already started reworking it so it will get through these 8 holes that we need to do. Now let me show it to you super quick, and then we'll drill out these holes and then tap them. So there's a look at that shank. Now I've already aggressively went over this with a precision flat stone, and if you don't have a set of these, they're well worth the investment if you have some old tooling laying around or love doing machine work. This was a game changer for me. It really opened my eyes to bringing to what a person could do at home in the shop without a precision grinder to bring precision surfaces back that are damaged, back to acceptable condition. So this is dinged all to pieces, it was. And I just went over this heavily with this flat stone. The thing about these is that they're so flat, and you're working on what was a flat surface, and the majority of this surface is still flat. It does have some big raised dings on it, and where these come in is when you're running it over a precision surface, where they're both super flat, the stone basically stops cutting. It doesn't have enough pressure on one given area to remove hardly any metal. But once you get to a big raised ding, this thing will just eat away at it until it reaches back down to that original ground surface, and then it pretty much stops cutting. So you can really save old tooling and stuff, or even, make sure your new tooling is not dinged up with these. So there's the shank. I think it's good enough. If we stuck this in there as is, it probably wouldn't even hold. It was so bad. It'd probably just fall out. Or it would transfer some of that damage that's on the shank of this drill into the socket of the drill in my drill press, or, the adapter or whatever you're putting it into. So there's a look at the cutting edge, the end. It's been hand ground. I did check it just to make sure that it is proper angle. Each flute is of the same length, and it seems like it's going to be okay. If it's not, we'll take it over to the drill press and touch it up ourselves. So there's the drill bit that I brought back from the dead, basically. Let's see if it will eat away at the stainless and not give us any trouble. Cutting pretty good. A little aggressive on one flute than it is the other, but So that drill actually done really good. Not like a brand new drill, but not too far off of one. Good enough. So I'm going to be tapping this on the drill press, not using the drill press to run the tap, but using the drill press as just an alignment tool or a tap guide. So I've got a chamfer tool in the chuck and all that to make sure that the hole is directly underneath the chuck. So we'll do that, and it's going to work as an alignment tool for my tap. I think got a little bit of the Molly D. Love this stuff for stainless. So I'm just going to get that in there and line that up on the back of this tap. And I'm just going to use one hand just to get me started. That way I'm get started good and straight. And there we go. They are all tapped. This is a plug tap, which is perfectly fine. I don't need threads all the way to the bottom of the hole. Studs are just going to get Loctited in. Now I'm going to use this chamfer bit. Just come in here and burr these holes. And this will be done. Other than putting the studs in it, that is. So there we go, quick look. I don't have the studs yet for this thing. It'll just get 3-inch studs. They'll get screwed in. They'll get Loctited. You know, there'll be a gasket. You know, that'll slide over a nut and a washer, and boom, this thing is sealed and adapted from 8-inch to 4-inch in a short amount of space. You know, no leak path through the threads. So that should work good for its intended purpose. You know, this, like I say, this is not going to be a pressure unit by any means. It just needs to work, and we need the stainless for the corrosion properties, anti-corrosive properties. So for removing layout fluid, I like this SuperTech carburetor cleaner. I used to get this stuff for 78 cents a can. Now it's like $3 and something a can. Still good stuff, but that's what I use. Works great for removing layout fluid. So I've got the other flange in the lathe here. Now this one I'm going to do a little bit different because the hole in the center is a bit smaller. 2.45 inches is what I need to drill out the center of this flange to. And because I don't have a trepanning tool ground up that's would work really well for this thick of material and that size of hole, what I'm going to do is pilot drill it and then step drill up to the biggest drill that I have that will fit in my chuck, which is 1.5 inches, And then we'll come in with the short carbide boring bar and just plunge it out. It shouldn't take long. You know, we don't have a super big distance to go. If it seems like it's going to take me forever, then I'll readdress. But I think that I can knock this out relatively quickly, just stepping my way up through this hole. So we're starting out 1/4 inch. That'll be a really good pilot, you know, get us going through this, get us a good starting hole. I'm going to speed this up for just a small bit. Step up. Slow it down a bit. Let's try 78, see what that looks like. That's still fast. 42. Better. So that drill wasn't cutting the best ever was, but it did leave a pretty nice finish in that hole. Not that it matters, but done just fine. That's hand ground. So a good chip hook is a must. This is just made out of a bandsaw blade and some PVC. You could do even wood or whatever. Grind you, use a little Dremel tool, grind you a hook on the end. Boom. Got yourself a pretty decent chip hook. So last cut, 70 thousandths. This does not have to be a super precision hole. So this is the last cut. Whether it's a few thousandths big or a few thousandths small, for this it doesn't matter. So 70 thousandths, final depth of cut. Make one pass, maybe a cleanup pass if it needs it, but probably won't. Going to do it. We're after 2.450, 2.451. That's close enough. So boom, there you go. Two flanges, machined in kind of two different ways, but for the same outcome. So these flanges are pretty much done, and the research project that they're for can just sail right on. The step's done. So trepanning this larger hole for me made more sense than drilling to a smaller size and then boring for, you know, an hour. It's going to depend obviously on the tooling and stuff that you have, the equipment, the method that you would use to do something like this, but I used two different. I step drilled and bored and just trepanned this one. So there you go. All that's left, because they're not quite done, is for me to clean out these holes really good and then Loctite my studs in. But I don't have the studs yet, so as of now, these are finished. So there you go. So I want you to feast your eyes on a top notch, and I'm telling you, this is a top tier shop supervisor right here. That is Cora Lou. She showed up here as a stray a little over a year ago, I'm thinking, and she pretty much has not left our sides ever since. She's like my shadow, my shop shadow. She does a great job of supervising, usually from this area right here, keeping us on track and on budget. You know, listening for burglars constantly. You would not want to break in this shop with this little dog right here on the job. You'd regret it. So, all jokes aside, she is an awesome dog. I couldn't ask for a better dog than little Cora Lou. So we were really lucky she showed up. As far as the machine work that I did, pretty much basic stuff. Hardest part, bulk material removal. And stainless kind of, you know, ups the hardness level of that job a little bit as well. But no more, no less than what the people who wanted asked for. I think they're going to be completely happy with it. It should do what it is designed to do. Trepanning, it's the fastest way that I have in this shop to remove big chunks like that. You could, or I could, have set it up on the milling machine, but my rotary table's not big enough. There's lots of ways. I said it before. You could water jet that out. If you had a big CNC milling machine, you could clamp that down and buzz that out. I don't know, CNC lathe, lots of ways. But in my shop, those two holes of that size, that was the fastest way that I know to get those holes opened up. So that is it for this week. Thank you for watching. Viewers, patrons, subscribers, anyone who's helped me out whatsoever, it is much appreciated. I do have a video on Johnny Cash coming out here soon. So that's it. Thanks for watching. and I'll see you next time.